All right, continuing on with week 4, day 4 video. Yeah, second video. So here's an application of cosine law for finding distances between two horizontal points A and B separated by some object or something that deters you from measuring the distance between them. So sort of, let's say you're surveying and you're at A and there's a huge body in between. You cannot measure the length across it. You still want to find the distance between A and B. So the strategy is like this. Because you're on this side, you can make measurements here. So from A, you find a point C on the same side, right? And then what you do is make sure you can still see A, right? Now this distance can be measured, and when you are surveying, you have instruments which help you measure angles. You can measure, so make sure you find this point C from where you can see both A and B, and that's important. And then you measure these angles, so angle of A as seen from C and angle B as seen from C. So you have this distance, yeah. AC is known, okay. Angle A, angle B is known. So you know these angles. So using that, you can find this unknown. So let's see how we can do that. I'm going to do it abstractly, not with the numbers here. First of all, once you have these angles, you have this angle, right? So I'm going to put a tick mark on things that we know. Once you have this and you have this side, you can use sine B over AC equals sine C over AB. Let's see. We know AC, we know angle C, we know angle B, so we can find this. Okay. Now you could also apply cosine law to find angle C, but I think it'll be easier if you already have the angle measuring instrument and you measure these angles. You can just use sine law. Okay, next example, combining something or reiterating something we did earlier this week is when there are no triangles. Yeah, this is not a triangle, and asking you to find AB. So we're gonna use some strategy that we have used before, which is, let's see if I can form a triangle somewhere somehow. Right. All right. So if I take this point B and I run it across, it's gonna hit this somewhere. Let's call it C. Then I know in this triangle, I know this length, 3.6. Okay. Not sure if that's gonna help me. Oh, I see. Scratch that. So the reason that's not going to help me is because these are not right angles, so it doesn't give me any information about these lengths. Now based on what I have this length, and this is 80 degrees, so it's not vertical. I'm going to break it into the triangle in this fashion. Right? It's because then at least the numbers or the values that I know correspond to sides of some triangle, right? Unlike what I did before. Okay, now triangle ABC, there is not enough information. Alright, just one side and one angle, it's not very helpful. Triangle BCD, that looks good because I have two sides and an angle, alright? But where's the angle? The angle is between the sides, yeah, so no sine law. what I can use is cosine law, right? BC squared then is the other side, so 0.7 squared, 3.6 squared, minus 2 times 0.7, 3.6, cosine of the, what's opposite BC? And I know that angle is 80 degrees. Okay, I go on to my calculator. 0.7 squared, 3.6 squared, subtract 2 times 0.7 times 3.6 times cosine of 80. Again, this is BC squared, right? So BC is the second, giving me square root, second answer. Square root of answer. I need two places, so 3.55 meters. Great. So I now have more information. Yeah. Now triangle ABC, I have this angle, and I have this side. Let's see, can I use sine law? I still need something else for applying cosine law, yeah? Because with AB, I don't have this angle. But I can find angle B. So let's find angle B. I can do this because I know the side. So 1.3 over sine B is 3.55 over sine 110. Yeah, cross multiply. 1.3 sine 110, 3.55 sine B, divide sine B, 1.3 sine 110, 3.55. Let's go to the calculator. 1.3 sine 110 divide 3.55. Keep in mind that's not my final answer. Yeah. Second sine inverse, second answer. So B is 20.13 degrees. All right, now I can find AB, right? Because angle C is now 180 minus 110 minus 20.13. 49.87 degrees. Perfect. Finally, I can find AB, because AB squared now is the other two sides. So 1.3 squared, 3.55 squared, 2 times 1.3 times 3.55 times cosine of this angle opposite to AB, which is C, which I just found to be 49.87 degrees. And so I can just go to my calculator now. Here, make sure you can see 1.3 squared, 3.55 squared, 2 times. Keep in mind that's not AB, yeah, that's AB squared. So I go second square root, second answer, 2.888 rounds to 2.89 meters. Okay. So not a straightforward path, but we're using, it's not enough information. So I use sine law to find BC, then I use sine law to find angle C, then I use cosine law to find, I first use cosine law to find BC. Then I used sine law to find this angle. Then I went back to cosine law to find the unknown side. Alright, last example. Determine angle A of this structural frame. Where is A? Oh, A is right here. It's not quite vertical, so let's see. There's a lot of values given here, right? So we need to strategize. First of all, it's not right angled. Nothing is right angled here as far as it goes because it's not given to be. Okay. So let's focus on this triangle. Well, one way is somehow find the two remaining sides, right? So let's label this X and let's label this Y. So let's try to see how to find X and Y. X is fairly simple, right? I think so. Let's see. If I call this A, then X is just 15 feet minus A. Okay. I can find A because if I can find A from this triangle, that would be nice. For finding Y, if I can find this side, that would be nice. I don't think I'm missing any information. Let's see. The thing is, I don't know this side. I have an angle and I have one side. That's not good enough. Because that's gonna give me this side, but not this side. And I have this height, but not this height. Maybe I am missing some information. Okay, I can't pause this video. So I'm gonna, again, post this as a separate video. I need to check. Probably made some error copying this from the textbook. Okay, that's the end of this video. This problem will be in the